In this video, I want to run through the sort of standard methodology to compute limits at infinity when you've got a rational function, for example, a polynomial divided by a polynomial. So here's one such example. We have on the top a polynomial x cubed plus 2x squared minus 1, and on the bottom we have 3x cubed minus x plus 7. And the question is, okay, what happens as my x gets bigger and bigger and bigger? Does this function approach some value or does it not? Now, the first thing I want to think about is, let me just look at the numerator, the x cubed plus the 2x minus the 1. If my x is really, really large, like a million or a billion, the minus 1 doesn't really matter. We'll have like a million cubed out the front, and that'll be an enormous number, and if I subtract 1 from it, it will be an enormous number that's more or less the same sort of number. Minus 1 doesn't really do much to it. And likewise, the x squared is big, that's a million squared, but a million squared isn't remotely as big as a million cubed. So I'm going to say, if I'm just sort of approximating and waving my hands, that the top, its sort of size is determined by the largest power, by the x cubed here, that this really is the thing that sort of defines how big the numerator is growing. But on the bottom, we have a similar scenario. I have another term, a 3x cubed this time, and we also have a plus 7 and a minus x, and those really don't do anything compared to the enormous size of x cubed as my x values are getting really large. So if I'm going to do a sort of naive computation, as in I'm just sort of guessing what it is but not showing it formally, I'm going to guess that the thing that really matters is that this is more or less an x cubed on the top and a 3x cubed on the bottom, and that therefore the x cubes are going to cancel, and then what I'm left with is just going to be 1/3. So that's my guess, but I don't like just guessing things in mathematics. I really want to know that they're true. I want to make sure that I'm using proper theorems and that I haven't made any logical errors. So let's try to rigorously do this. So instead of the naive assumption, I'm going to try the following trick. I'm going to take the top and I'm going to multiply it by 1 divided by x cubed, and I'm going to divide the bottom, or take the bottom and multiply it by 1 divided by x cubed. I haven't done anything, right? The top and the bottom here are the same thing, so I don't make any change by multiplying this. All right, so in my limit, taking the limit as x goes to infinity, just copying and pasting that. So I'm going to take this and factor this in. So x cubed is going to become a 1. X squared divided by x cubed is going to be plus twice, and then I have a 1 over x. And then minus 1 over x cubed. So that's what the top becomes. And then the bottom, 3x cubed divided by x cubed just becomes a 3. X divided by x cubed is going to become a 1 divided by x squared. And then finally a plus 7 divided out by x cubed. Now, I think that this is nicer because I can focus in here on all of these 1 over x squared, 1 over x cubed, all of those terms. Because the limit, as x goes to infinity of 1 over x, I know what that is. This term here is just going to be going to 0. And 1 over x cubed is going to be going to 0, and 7 over x cubed is going to be going to 0, and 1 over x squared is going to be going to 0. All of these things are going to be 0. These are known limits at infinity. And then what this means is I can use a set of limit laws, like for example, that I can take the limit of a sum and say that this is just the sum of the limits. Or if it's non-zero, I can take the limit of a quotient, and that's the quotient of two limits. So we have all these different limit laws, and all those limit laws are going to repeat themselves for limits at infinity as well. And so, since I individually can do these things, I am now confident, and I can step forward and say that this truly is 1/3, because I'm evaluating all these limits, setting them to 0, and what I'm left with is the 1/3. And so now my sort of naive computation, I've verified it, and I've shown the mathematics by multiplying by 1 over x cubed and dividing by 1 over x cubed that gets me to this value of 1/3. Okay, so now a second example, almost the same. I really only changed one little thing here. I put the 4th at it. So now when I think about it, it's sort of like an x to the 4th on the top that dominates and an x to the 3rd on the bottom that dominates. And then when I look at that, x to the 4th over x to the cubed is just like an x, and the limit of x as x goes to infinity is infinity. So I'm guessing that this is going to diverge to infinity, but let's check it. I can say that this is, in our same way as before, the limit as x goes to infinity. Now I'm going to continue in my same way. I'm going to do my same trick, and I notice I've got x to the 4th on the top and x to the 3rd on the bottom. So I'm going to do the same thing, 1 over x cubed divided by 1 over x cubed. This is going to get me the limit as x goes to infinity of, well, it's just an x, and then it's all the same after that, plus 2 divided by x minus 1 over x cubed, all divided by 3 minus 1 over x squared plus 7 over x cubed. And we can say that this is going to 0, and the 1 over x cubed is going to go to 0, and 1 over x squared is going to go to 0, and the 1 over x cubed, all of those factors are going to go to 0, but the key thing is I've got this x here. And so this is the limit as x goes to infinity of x divided by 3. And so this is going to diverge to infinity. So we have to be very careful about sort of looking at this highest power on the top, highest power on the bottom, and seeing what's going to happen. I'll do one final example for you. I changed the same thing again, this time by putting it as x squared opposed to x cubed or x to the 4th. So now the highest power on the top is 2. The highest power on the bottom is 3, so we think the bottom dominates. It's going to look a lot like 1 over x as it gets large. And we can do the same trick if we wished, I won't fill it in, and say that because the top is x squared, the bottom is x cubed, it looks like 1 over x, and 1 over x in the limit as x goes to infinity is just going to be equal to 0. So indeed, we've seen that for these rational functions that we can go through the process formally by finding whatever the highest power is, the top and the bottom, and dividing the top and the bottom by that highest power. And if the top and the bottom are the same power, it's going to result in some fraction, and sort of naively we can almost just read it off, although I want you to write down the steps. Or there's more powers on the of x on the top, in which case it diverges to infinity, or more powers of x on the bottom, in which case it's pulled down to 0.